Good morning. Let's get up, set up to do some work. Why don't we? All right. So today I'm going to be working on movement stuff. Again, still. And we'll be seeing what we can do. Basically this week and next we'll be working on a lot of abilities for Bitey, getting him moving across terrain properly. Things like that. Let's see, what do we got right now? Well, what we've got right now is Bitey just not doing a whole heck of a lot. Now, one of the things I noticed earlier was that in one of our levels, Adam created this cave level, and I think I was having trouble standing on some of these objects. So what I'm going to do is I'm going to copy one of these objects over. Oh no. So let's get this thing moved over. And what I was seeing was basically on this 3D object that I was having trouble standing. It was basically doing some ray casts straight down or whatever, and the character was falling. Alright, so let's go take a look. Yeah, that falling animation stuff there is what I was talking about. And I think it's the board animation is just not hooked up. So what we need to do is go change our Bitey movement to not have the board movement state happen. So that's in stationary. We've got this animation event on end here for this board, and I'm just going to go ahead and remove it. Because let's see if that actually works, because I think what was going on is basically our board animation is got the wrong collision and stuff like that on it. Well, let's just double check it. So you should not be falling off anymore. Yeah, that looks like it's working a lot better. Excellent. Alright, now the next thing that we want to do is this jump is just too slow. Because we got that animation there that we actually play. So where is it? Let's see. Because we got our states, we want to go to the movement controller. For the player. And we've got this whole animation that we play. Let's see, where is it? It is here. And we've got it as like 10 frames for the duration. But I think what we're going to do is basically... Yeah, welcome Slade Iolacorp. Thanks for stopping by. We're just getting started here doing some Unreal 4 development. Yeah, don't worry. Everybody says, oh, my bad English. Yeah. And then always has perfect English. So, I want two things in here. I want a speed at which we're moving to skip the animation stuff. And good project. Alright, well, thank you. We want two things. We want to be able to cancel out of this if we're moving a certain speed, and we also want to speed it up. So let's just speed it up here just to begin with. And maybe this duration we can also change based on our speed. So this is the jump animation. I guess we can make the animation faster if we're running. So let's see, do we have the get unlock animation, get flipbook? I think I want to go to this after image effect. So this is the jump. Alright, so we're going to get the vector length of the velocity here. Thank you for following Slade Iolacorp. I am not an artist. I am an engineer. So all the art is done by Adam Phillips. So let's see. So I want to basically say, like, if we're moving at a certain speed, then I want the duration to be 0, and I want to actually start jumping. So I'd actually want to... If that's false, we're going to skip all this logic. So physics state is on the ground, and we're moving. I basically want to jump right up here. So I have to think. We could just play, you know, like one frame of the animation. We could just say, if this is greater than this, then the animation time is 0. Or what we can do is I want two things. I want this to go from... I guess I could just go ahead and move it from 0 to 2500. Yeah, why don't we have like a... So if we made a variable that's basically our jump, let's see, this is play no anim threshold, play no jump anim. Let's make it a float. Let's give it a default value of like 2500. And let's do another variable for jump anim. What else? I guess this would, we don't actually need this. We can remove one variable here. Basically, I'm kind of kicking around in the back of my head at the moment is we want to go from like 0.16 to 0, and what we want to do is get a multiply that. So we want to multiply 0.16, and we want to multiply it by the divide. We want to take the current speed and we want to basically do this vector length divided by is there like a min? And then we want to multiply this by that, and that's going to slap into the duration. It's going to go from 0 to 1. I want the opposite, actually. I want 1.0f minus this. So let's do a subtract. So it's going to be 1.0f minus this multiplied by 0.16. And I guess we're going to have a one frame window here for the jump. Like this is going to go to 0, so we're going to just not even play the jump animation pretty much. So we need to snag this guy and actually put it through like this. So let's organize this blueprint a little bit, make it prettier. Alright, so what this will do is it'll speed up our animation going from 1 to 0 multiplied by 0.16, which is 160 milliseconds. So what we also want here is basically if we want to jump or all this, if our speed is a certain amount, then we want to skip all this jump animation stuff and just go ahead and play it. But what we want to know is if our jump animation is already playing. So if our jump animation is already playing, we want to stop it. So we actually want this condition here, and then I guess we want to run into this whole area right above it. And this is not on the ground, key triggered, jump grace period. Yeah, okay, here we go. I need to call this get velocity. And we'll get this, and we need a greater than. So it'll be a float greater than a float. Actually, I want a greater than equal to. So it's basically we're going to say if this float value is greater than 2500, and our jump animation, yeah, it's going to need to be actually right down here because we need to make sure that this animation doesn't get all screwed up. So if the animation ID is So it's going to be right here. So we'll need a branch, and here we go. So this is false, so we are not currently playing any animation. We're going to need a branch here, and if this value is greater than 2500, we need to just go into our normal jump up there. Otherwise, we will play the jump animation and then jump. So if you're moving fast enough, when you hit the jump key, it's not going to play the jump animation. Otherwise, it'll play a sped up jump animation based on your velocity and all that. What a crazy spider web of stuff. And this shouldn't be 2500, it should be this play no jump anim speed. So let's test it out. So if he's not moving, we play this jump animation. If we're running, we just immediately jump. And that kind of a pause that's happening right there is that landing animation that's playing. Alright, so we got that sorted out. Awesome. So what are we going to do next? Because we're sticking on this rock nicely. Alright, I need to figure out what I'm doing here. I think what I need to do is reorganize the animations so that I have the correct... Yeah, our animation stuff right now is incorrect. It's... At the moment, we've got all our animations in this complicated data structure hierarchy thing, which is like based on type and set and some other strange stuff. And what we actually want is our animations just to have names. Because we were trying to make this more complicated structure of kind of the movement controller owning everything. And that really didn't work too well for us. Because right now we've got like the idle animation set, which has stationary, which has animations, which has all this other stuff in it, and to put all this together you have to mess with all these different animations, which don't really work too well. Alright, let's see. Alright, so we fix this. Fix that issue. We got the that. So what we want to do is we want to change this into just a simple single list. Because we don't need these animation types or any of that. We just want lists of animations. And we don't need any of this other stuff. We don't need like these sub animations and all that. We can just, we're gonna hook that up in logic instead of having a ridiculous complicated data structure thing deal with it. What this means is I'm gonna have to break a whole bunch of stuff to kind of switch over. I'm gonna have to break FatSack. Because FatSack right now looks like this. But there's not too much to FatSack, so not really much there to break. So I think I'll just take a screenshot of all those so I know the names. So I've got all of those, so I can throw that off on my other monitor here. And we'll exit, and then let's go change our data structure. So it's the Dashkin entity data structure, I believe, has all this stuff on it. Because we have this animation wrapper, and the animation wrapper is the thing that's actually on there. So what we want to do is we want to get rid of this animation wrapper extra data. We don't need it. We don't need this animation transition stuff. Alright, so this animation set group we don't actually need anymore. We're just going to have animations. So instead of all this stuff here, basically we just have a list of animations. And this is generated code, so I'm going to need to edit the template instead of editing it directly. This is inside of entity stuff. Alright. I'm still just kind of waking up today. It's kind of blah. So I'm just kind of rambling. Not really centered. Not really getting everything that I want put together. Alright. So our generated code means we have to edit the template and then we'll generate it out. So we don't have this entity animation set group anymore. We don't have these types. We just have the animations. Alright, so yeah, we pretty much, this whole class seems like it's type in set no longer exists, so we're just calling get animations. So we'll just append the animations to the incoming vector. So we can just get rid of a whole bunch of code, basically, which is just fine with me. And this is going to piss off a lot of the stuff, a lot of the systems that use all these. Like the movement is just going to be totally broken, so we're going to have to go fix it. And then we're going to have to re-drag all of our flipbooks in there and get those set up properly. Yeah, we just have the flipbook and the unique name, and that'll be enough. Alright, so let's generate that code. The software that we use to create the actual creatures and Bitey and all that is Toon Boom Harmony. So I can pop that open real quick if you want to see it. So let's refresh this and get all the new stuff. Yes, this is Toon Boom Harmony, and basically we've got our guy all rigged up here inside of Harmony, and that's where we use to animate, and then we export it in a series of sprite sheets. Which look like this, where we have like our sprite sheets get exported, and we've also got like our sprites get exported, and we've also got our normals, all that. So let me combine all that stuff inside of Unreal. Alright, so I think I also need to remove the enums inside of here. I'm basically going to have to get rid of a whole bunch of random stuff that we've been using for data. So let's just go ahead and rip it out. So we're in data. Let's see, animations. It's probably inside of movement, where I've got the definitions for all the different types of movement data structures. No, those are movement controllers. Yeah, all of this stuff we don't need. Like, we don't have these anymore, and these are just lists of animations that really aren't helpful at all. So, yeah. Since we're just getting rid of it, let's just go ahead and get rid of it. Looks like all of it is garbage. So if we get rid of it, let's see if there's any problem inside of our generation. Let's see, animation constants.h. animations. So this is animation constants.h. Alright. So generation, templates. This is just one of those, it's easier to get rid of, it's easier to write new code than it is to get rid of existing code, so fun times. So this is the animation constants. I personally don't really know Toon Boom Harmony that well at all. Adam does. He's the guy, if you want to follow, who knows a lot more about the art and animation. But he's been using Toon Boom for quite a while, and it's not an easy program to learn. I think he actually teaches courses on it. It is a gigantic pain in the ass. Yeah, these all look like Dashkin animation set items that we don't need anymore. So we can just go ahead and get those and get rid of them. So let's look at the animation constants.cpp. Yeah, we don't need any of this stuff. And we also weren't able to use a lot of Toon Boom stuff out of the box, like to export our sprite sheets and all that stuff. We had to write custom scripts inside of Toon Boom to get it to do what we wanted. Doing stuff like rigging up the collision boxes right there on the object, not something you can normally do. Alright, so let's go ahead and compile this and see where all of our nasty errors occur and start fixing them. And I had made all this stuff a while ago, and I had made it so we'd build like this complex system where if we had the animations hooked up, then it would automatically play the animations that you want, and that has proven not to be fun at all. Pretty much, we spent a lot of time trying to make a system that would automatically figure out what you're supposed to play, and at the end of the day, it didn't work. It was not super easy to use, and it was like basically the difference of making a big system that should be able to figure out everything versus just making systems that know everything about themselves. So let's see, I need to open up the movement object. Alright, so get movement set. Yeah, we're just going to be getting rid of a whole bunch of stuff here. So get movement set. We don't want. Can play animation. Yeah. This is gonna take a little while to actually get back to where we just were, because I have to remove a whole bunch of stuff, and removing stuff just takes a lot of time in C++. And I gotta break stuff. It's just one of those things. Alright, so the entity animation controller component. I have to fix that. Good morning, Karakan. How are you doing? I am still just kind of waking up. You probably will be for a while. It's basically, we're getting our animation IDs by name now, pretty much exclusively. These animation types are just not things that we need. Too hot here. Break stuff. Because I'm redoing how we hook up our animations, so that it's all based on the string names instead of based on a category and a subtype. Basically, what it used to be is we had it set up so you would have a movement type, and then you would have a movement speed. So to get an animation, what you would do is you'd say, okay, well, I have an animation which is a stationary animation, and I want the idle for that. Or I am running, and I am idle for that. So we have this like lookup here. You'd basically say like, okay, well, I want the idle animation, and then it would have, like stationary, walking, running, etc. And kind of we would first look at this category, and then we would say, okay, well, you're walking, so this is the animation play based on your speed. And what I'm doing is I'm taking that out because that system was proving way too bulky and cumbersome. So instead, it's just like inside of your movement controller, it just says like play the walking animation, as opposed to saying play the idle animation for walking speed. Just because it's just not necessary to have all this garbage in there. It's too difficult to deal with, so getting rid of it. Making it much more direct. Yes, that is exactly what we're doing. And that's because making it direct is what needs to happen now. Basically, if I pop open my documentation for this thing, it used to be that we just had this movement controller as like a big C++ monster, but we found out that we needed movement controllers to be blueprintable with movement controller states. And these, if we have to make these states know a lot more information about what's going on. So since we already have all this like specific logic for our movement, like there's no sense in having this thing be super complex for no reason. Alright, so we get animation by type and set. name and type, random animation ID by type, random animation ID by type and name. Alright, so let's try that. Streamlining is good. Well, it's kind of the opposite. It's instead of trying to make one giant super smart brain system, we're making it so everything's kind of distributed, so all the complex logic is actually can be located locally. So it would be like your hand figuring out how to pick an object, you know, how to close itself, instead of having like your central brain figure out everything about a character and like, okay, I need to pick up this boulder, so it's gonna be like, okay, you know, legs need to bend, this joint needs to do that, you know, hands need to close and do whatever. It's more like, okay, legs, you're supposed to like stand up, and hands, you're supposed to do whatever, and then the hands figure out like exactly how they should move to accomplish the action, instead of having a central control have to know every damn thing ever. Alright, our animation constants and all that need to be since we don't need there's nothing in that file, it's just going to cause a whole bunch of issues. So let's regenerate. And it's already Wednesday. I don't know what the hell happened yesterday. But yesterday is gone. Let's never speak of yesterday. It was not fun. What? I just spent yesterday doing like absolutely nothing. You guys spent all of yesterday just like watching One Punch Man and shit like that. Practically impaired by the heat. Jesus Christ, like what kind of... Do you live on the surface of the sun? Like I know you're gonna like go watch Cars or whatever, but... Jeez. Get an air conditioner. Though I'm pretty lucky, like, I've got my basement, which is legitimately a good, like, 10 to 15 degrees cooler than the upstairs. Like, I live in a kind of a small place, but the basement is as big as the main floor. So it's this nice, big, cool area that is always comfortable. It'll be like, you know, 100 degrees out or something, and my basement's still like a good 75 degrees or something. and I don't even need air conditioning. It kind of just acts as a giant battery with the ground cooling it. Yeah, perfectly temporary. This is true. Alright, so we're going to call play by ID on the animation controller. We probably want loop to false by default. The duration should be the flipbook. I'm going to have to figure it out. Let's see, play direct is on the animation controller component here. Duration is not supposed to be anything, so we want to get the actual duration, I guess, off of the anim data. So I'm guessing we should get total duration, should be? Yeah, okay, that looks good. You want the crypt back? Yeah. It's pretty nice having a crypt. Like, we had a whole lot of ideas for this thing beforehand that we don't do anymore. Because now we have different ideas. Yeah, I had watched like One Punch Man a couple years ago or something, so I'm rewatching it because I can. Let's make sure we get our null pointer checks in here properly. I skipped a few. Alright, so that should definitely help those out. Alright, that looks good. Let's continue to fix everything. Alright. Get animations is not a thing anymore. Wait, what? This is entity animation controller component? Entity animation controller. Well, let's take a look at this. Yeah, that's pretty much the idea, was do something along those lines, because just having too much trouble get animations is not a function. I'm having trouble, like, where is this? This get animations function doesn't exist? Oh, it's right here. Okay. It's like, where did this function go? Yeah, well, the main thing there, Karakan, is if you have to, like, let's say I have Bitey and I want to play a different transition animation between running and sprinting. If in order to do that in the previous system, I would have to change the logic that changes everything. And I also need like a way to inform the system that this transition exists. And I need to like hook everything up, and then, you know, it's just kind of one of those things. Alright, so this is Dashkin mdata.h. I need get animations. Alright, so I guess we have to do for every, yeah, for n32i equals 0, I is less than. I guess what I could do is just have the animations here and then have animation pointers. Well, where does this even get called? Yeah, I was just trying to use an analogy that somewhat makes sense. Alright, well, where do we actually call get animations in our project? Looks like nobody even uses this thing. So maybe I can just change this get animations. I'll just change the function entirely. So yeah, I'll have two of them. One which takes a reference and the other one that returns a reference. We'll have get animations and append animations. Yeah, the other thing is it should be a lot easier to work with. Because when you go in and change something, you're only going to be changing the thing you're working on. You're not going to like have to touch the thing that touches everything else. So if you go in there and add a dash for Bitey, he's not going to screw up Fat Sack rolling around. Though on the flip side, if you fix something with Bitey's dash and you want to use that same logic inside of like Fat Sack's roll, you're going to have to copy paste it. So it may be that you're fixing the same bug multiple times. And this is kind of the difference that, you know, that's where both sides have decent arguments on what can be done.